Hello everyone, Mathemagic here. Today I am very glad to announce that the RMO INMO series, where we will discuss previous year's question based on these exams, is here finally. And today we will have the first video of that series, and it is the first question of the 6th Indian Mathematical Olympiad from the year 1991. Alright, the question says find the number of positive integers n such that n is lesser than equal to 1991 and n squared plus 3n plus 2 is a multiple of 6. Let's start. First of all, we can write f of n equals to n squared plus 3n plus 2. Now we can factorize this and get n plus 1 into n plus 2. Notice, if n plus 1 is odd, then n plus 2 must be even, as it is just the next integer to n plus 1. And if n plus 2 is odd, then n plus 1, being the previous integer, must be even. Therefore, the whole fn must be divisible by 2. Hence we can write 2 divides fn. So we just need now to prove that 3 divides fn. If n plus 1, or let me say n equals to 3k plus 1 for some k belongs to I, then we have n plus, or better 3 divides n plus 2, because you see n plus 2 is 3k plus 3, which is 3 multiplied by k plus 1. Therefore 3 divides n plus 2. Therefore we can say 3 divides fn. Again, if n equals to 3k minus 1 for some k belongs to integer, 3 will divide n plus 1. Now you see 3k minus 1 plus 1 will cancel out the 2 1 and we will be left with 3k. So you can write 3 divides fn. Hence, only for n equals to 3k, k belongs to I, neither of n1 n plus 1 is divisible nor n plus 2 is divisible. For example, let me take value of n as 3. We get here n plus 1 is 4 and n plus 2 5, which gives us 20. Now 3 is not divisible, or 20 is not divisible by 3. Again, if we take another example, for example say 6, then we see n plus 1 as 7 and n plus 2 as 8. Therefore fn is 7 into 8, which is 56, and therefore 3 does not divide 56. So only for 3k n doesn't divides f, or 3 doesn't divide fn, and therefore 6 doesn't divide fn. Given that, we need to find now, there are two ways to find the number of solutions. We can either find all the possible values of n for which 3 divides fn, or in other words 6 divides fn, and another way, which is to find the solution, is which is I prefer it, is that we can find the number of solutions for which n does not divide, or 3 does not divide fn, and then we can just subtract that from, we are already given that n is lesser than equal to 1991, so we will subtract that value from 1991. Alright, so let's get on with the second one. So we need to find n lesser than 1991. Now this is the case 1. Given that 3k is lesser than equal to 1991, we have k is lesser than equal to 1991 by 3, or k is lesser than equal to 663. Given that number of integers satisfying 1 and 2 equals to 1991 minus 663. So are you ready for the solution of the first INMO problem, which I am solving is 8231, or 1328. So the answer for the first INMO question of our series is 1328. So that was the first video of this series. I will try to bring lot more videos, and I know that I am giving only number theory questions till date, so I will try to give geometry, combinatorics. I'm also working hard on combinatorics so that I can solve questions in a easier way than we think, and share those things with you. So stay tuned to these videos, stay tuned to our channel, subscribe the channel, like the video. Thanks a lot. Goodbye. Have a nice day. Bye.